Hi everyone, it's Mathieu from Penax, and today we're going to talk how you can create your own ERC20 API with your own data extractions. So today you're going to learn how you can create your own API that is going to look like this. So you're going to have an API that can give to your user info about your supply of contracts, the balance, the transfer of user, all the holders of an ERC20 tokens. So we're going to teach you that today. So first of all, I'm going to show you what the architecture to make this API. So first of all, you need to extract the data from the blockchain. And we do that with what we call a substring. Substring, it's a powerful tool that help you extract data from the blockchains. So with those technology, we're going to fetch the data and we're going to store it in a ClickHouse database. I will explain you today why it's the best choice for your database. And finally, we're going to serve the data to your user with the APIs. So first of all, phase one is extract the data. Is the first step to accomplish this goal. So we're going to use substrings. The data we're going to extract today is a balance change. That is basically the balance an owner of a contract. All the transfers. So for example, this owner send 20 USDC to this person. We're going to have contracts info with the name, the symbol, the decimal. So everything that's more related to the contract itself. And finally, the total supply. So what's the supply currently of the contracts? So that's what's going to extract today. For the balance sheets and transfer, what we use to extract this data is storage change. So basically in Ethereum, every time there's a transaction, for example, a transfer, we have in the logs what we call a storage change. It's basically the value stored in the blockchains that say this person, for example, have this number of tokens and change to that number. So basically that's a storage change. With substrings, what we cool with storage change is very fast because everything is on transactions on the chains. So basically you just read the data and extract it. I will show you later what it call is and why it's slower, and we have no choice for the other ones. But for balance chain and transfer is very fast. So basically I will show you in the Rust code what it looks like. So basically when you're going to build your substrings, you're going to loop basically in every blocks in every transactions, and you're going to look for the calls. Basically it's when a function is called or a contract, etc. And in the logs of those calls, you're going to search for a balance change. In every logs, you're going to loop in storage change, and you're going to see if the whole balance and the new balance exists on those storage change. If yes, you have a balance change. You're going to loop in all those storage change and extract it in your sink more after that. So basically, it's very simple for storage change. When you want to extract, for example, the total supply and contract info, it's more complicated. For example, for total supply, there's no standard in ERC20s for example, minting, burning, or any logics that add supplies to the contracts. So basically, there's no way to detect it on the chains. The only way to read the total supply is to read the total supplies function that every contract of ERC20s needs to have. So you can read that with an ETL, but you cannot find the storage change on chains, basically. The problem with ETL is very slow because you need to make an RPC call every time. So for total supply, what we did is basically to detect the contracts is basically every time there's transfer on chains, so the more active contracts, we fetch any calls for those contracts. So basically what we did for total supply, so it's slow, but it worked. For contract info, because we need only one time per contract, yes, it's slow, but it gets fast later on because this is what we did with the small diagram. So basically what we did, we had a store in the substrings that basically is a key value pair store. Every time a contract is found, we basically just put a true value in the store. So basically we can have now a detection value. So is this contract already being detected? If yes, continue to skip it. And if not, make the ETL. At the beginning, it's very slow, but the more contracts we detect, the fastest it goes. So at the end, when the chain is full sync, it's going to be very fast. I'll make it calls. So if I go in the total supplies, what we did, we used the old balance chain substrate that we created. So we have all the balance change, and we look if the balance change. So we look the address of the balance change, and we basically make a small call with the ABI. It's a very simple function, and we call the total supply function from ERC20's ABIs, and we can get those values. So very simple, we do that for every transaction. So it's very slow. For the contracts info, we implement this very simple store, but helps a lot with speeds. So basically, we store for the key the contract address and a small true and false value. So if the contract exists, we do not make the call. If not, we do it. And it's the same logics pretty much for the rest of the substreams. Now that we have all those data extracted from the blockchain, we need to store it somewhere. On our side, we use ClickHouse. Why? Because ClickHouse is one of the fastest open source database for big amounts of data. Because I will show you what it looks like for balance change. So basically, this is a very few percentage of the chain, and I've already have 1 million, more than 100 million rows, and it's very a small percentage. So in the end, we're going to have billions of rows. So you need a database that supports big amount of data. And also, what's cool about ClickHouse is it's very optimized for real-time application with, for example, historical data. So it's pretty much our goal now for our APIs. So like I said, there's billions of rows we're going to have, for example, for balance change. So you need to also optimize ClickHouse, because ClickHouse is fast, but you need to optimize it the more you can, because it's going to be very slow. So the way we optimize it in our site, you need to order your tables with your blocks number or something that is very simple to order. For example, block number is very simple. It's incremental, so it's easy to order. But for example, if you use address, you can, but if for example, an ID is not ideal because it's random, so ClickHouse can't really sort it efficiently. So use something that's very easy to order, so that ClickHouse can very find the data you need the fastest you can. That's for the primary tables you're going to use. But for more speed, if you have the storage to have more storage, but you want more speed, you can use what we call materialized view. So for example, in the simple code, we order by block number and timestamps. So the primary table is ordered by that. So basically what it is it creates a separate table. It copies the data, but order them in another way. So for example, in our case, we create one for contracts and owner address. So for example, if you only want the balance of one owner, we use the material view for owner, so that ClickHouse is very fast to find those owner in the materialized view for owner. I don't know if you follow my logics, but that's pretty much what we did. So if I go back in ClickHouse Cloud for our case, for our test case, we have, like I said, balance a material view for the owner and a material view for the contracts. So for example, if I make a query for, in this case, I want the latest balance of our owner. So I want how many USDC you have. I specify the owner, the contract, but I use the materials view for owner because it's going to be very fast, because we specify a specific owner. We can use contract also, but in our case, it's faster with owner. And either by timestamp, because I want the latest value. So for example, if I run the queries, 0.6 seconds is slow. If I rerun it, 0.4, it's very dependent. 0.03. So it depends, but it's pretty much fast for the number of data we have. But like I say, with the full thing, we're going to have more data. So I expect a little bit more seconds when it's a full thing. So now that we create all that, we can simply create the API itself that read the ClickHouse data. So pretty much what we did is we did the same things for all the other paths for transfer, contract. So we make the materialized view for contract, total supply, transfer, etc. And we build a small API, very simple. So it looks like this. So we can fetch everything. We can now, for our side, fetch by block number. We can specify the name, symbol, etc. For example, balance change that we specified before. Yeah, we have timestamps, the chain, etc. So we can now give those data to our user. I hope this video helps you understand more how to extract data for the ERC20's tokens. So what's cool about that is that you can create your own from scratch. Other companies like Infura or Alchemy, you can pretty much create your own self-made ERC20's API's data. So that's pretty cool. So if you have questions, leave it in the comments. We're going to respond to you and help you create your APIs. I hope you liked the video, and I see you in another one. Thank you, and I see you later. Bye-bye.